Okay, everyone, we're going to transition to the next session. So the title of the next session is Technology, Hopes, Fears, and Unintended Consequences. And I'm very excited to introduce Derek Leben, who will be leading and moderating the session. Derek Leben is the author of a book called Ethics for Robots, How to Design a Moral Algorithm. So prior to coming to Carnegie Mellon and being a professor here at the Tepper School of Business, he worked at Pitt for many years in the philosophy department, and he will be talking to Rayid Ghani, who's also across the street. And he is a professor in machine learning for the machine learning in the Department and School of Computer Science here, and at the Heinz School of Information and Public Information Systems and Public Policy. He focuses on increasing the use of large-scale AI, machine learning, and data science in solving large public policy and social challenges in a fair and equitable manner. And he's known to also be the operator of the Data Science for Good fellowship that he started in Chicago and has now brought here at Carnegie Mellon. And then sort of to talk about the application of a lot of these concepts that both Derek and Rayid are researching and implementing into the organizations that they consult with and work with. Michael Barber is the Director of Data Science and R&D at Highmark Health. He's had over 20 years of management and analytics experience in multiple industries, and he has optimized scheduling and delivery processes, implemented lean and just-in-time production methods, and developed high-performing financial models. So I please welcome you all to give a big round of applause for our speakers today.
Any questions?
All right, thank you so much to both of our speakers for being here. We are here to talk about the unintended consequences of new technologies. It's the 21st century. Everything we do is, of course, quantified and recorded. Our location, our search and browsing history, our viewing history, our biometric data, if you're wearing an Apple Watch or a Fitbit, how well you sleep, your heart rate, if you keep information in your apps about your diet, your menstrual cycle, your exercise. This is all data which can be used and is used by companies. It's often put into very complex models, which are then made to use very accurate predictions and decisions. This is good for companies because accuracy is usually profitable. This is extremely important. If you're an advertising company, you want to make more precise targeted ads. If you're a healthcare insurance company, you want to make more accurate predictions about people's health outcomes. Any kind of company, transportation, credit, hiring, accuracy is very important. But the use of this data in these big, powerful models, which are often trained with machine learning methods, produces a number of problems. And so the first issue I want to talk about is really piggybacking off the discussion we had last time about privacy in the last session. But here I want to think about it in a new sense. Where we talked in the last session about HIPAA, traditionally medical data being used for medical purposes. In the 21st century, we now have the possibility that what we didn't think of before as medical data could be used for medical purposes. One could theoretically predict medical information about you from images of you, from other kinds of data that is not properly medical or maybe covered by HIPAA laws. Similarly, there are cases of medical data being used for non-medical purposes. In one of my classes, Ethics in AI, we talk about a case study from a journalist named Talia Shadwell who says that data from her menstrual tracking app was used to advertise things to her. When she missed one of her periods, she started getting ads for baby products. This is great for companies because there's a 9-month window that you can get in there, and it's good to get in quickly. But obviously, this is perhaps a misuse of medical data. So I want to ask both of our panelists about how, keeping with the theme of our conference, which is, I think, looking hopefully to the future and also staying practically with concrete examples, what are some impressive ways that you've seen companies in your decades of experience address some of these challenges with privacy and consent? Maybe I'll start out with Michael and then move to Ryan.
Sure, yeah, thank you. So Highmark is a fairly large company. We have 6 million insured lives, a few 100,000 people in our hospital system at any given time. And obviously that generates an enormous amount of data, tons of data. And we take it very seriously. You know, for us, it's an asset. We very much view that data as a company asset. But you know, what I will say is the way we use that data is very focused. Uh-oh, go ahead.
It's kind of going in and out.
Hello, hello.
There we go. That seems good.
Okay. So from the top down, and this was mentioned, you know, a couple of times today, where company culture really has to come from the top. Our culture is to use that data for people. We have, I can say quite honestly, because I've seen it, I've been involved in it, we have taken projects on that might have had some financial benefit. Turned out, after looking at things further, that the financial reward, if you will, was actually negative if we proceeded, but would help people and get the right kind of care, get them to the correct kind of, you know, PCPs, community services, whatever the need might have been. We proceeded anyway, even though that project ended up costing us money. So, you know, the last thing we look at, just very truthful, is the financial piece. We look at, will it help our members, our patients, our providers, health outcomes? You know, the more of those boxes we can check, the stronger the case is for any given project. And as far as the data is concerned, everyone goes through HIPAA training in addition to some other trainings. Everybody in my group has taken the city training, which is around you know, ethics in medical research. You know, there's a lot of training, there's a lot of thought about it, and we're very, very careful, far beyond what's required from a regulatory standpoint.
I know that, and I've had the pleasure of knowing you and knowing some of your team members, and I know that your team does care about this more than just in a sort of compliance or checklist.
Yeah, very much so.
Rayid, yeah. Would you like to speak about this?
Yeah, I mean, I think there are kind of two directions we can talk about. Right? One is when we talk about privacy. It used to be privacy was sort of a little bit simpler, right? We collect data or we don't collect data. That was kind of the life a long time ago. And then we kind of gave up on not collecting data because, as Derek said, data is going to be collected whether we like it or not, whether we want it or not, at least for now. So then we started thinking about, well, I can't control what you collect, but I can control what you should be able to figure out from it. Can you figure out if I'm pregnant? Can you figure out if I will have a certain disease? And that's less about data privacy. It's about sort of more about information or in technical terms. What can I infer about you, like inference privacy? And even there, we're getting to a point where we have so much data from different people. I don't need your data, because all of you here are probably very similar. We're all in the same city, same campus, same event, so we must have a lot of in common, right? So if one of you is willing to give me your data, I could probably figure out a bunch of things about each of you. And so I can't control that either very much. Now, so the more recent efforts have been in controlling what I can act on, like what are the actions, right? In the marketing world, that was always the case. Like all the credit bureaus, right? Their data can generally only be used for marketing purposes. Nothing else, just marketing. You know, and so not for product development, not for anything else, not for research, just for marketing. Whereas in kind of this space, we haven't quite figured out the regulations on the actions, what action can be done. You can have everything about me, you can figure out everything about me, but you can only use it to offer me, like what Michael's talking about, preventative services for healthcare, but not increase my premiums and not offer me products that don't concern. And I think that's, from a consumer side, that's very hard to kind of control, right? It kind of has to be done a little bit more templatized, where higher level organizations kind of offer you, here are three menus. Choose one or two or three, and maybe it's like the voting behavior. Like you're going to take this company or this nonprofit's advice on menu one, menu two. So I think that's where I would actually like to be a little bit more nuanced. Is offering, not relying on consumers to make that choice, but on offering them kind of presets on high, medium, low, and then they can start deciding. I think one thing I'd end with is a lot of work that I do with sort of governments and nonprofits around the use of data. We try to do, minimize the amount of data we're using, because it's too risky to have data sitting around. Like, if we're not using it, but if it's there, it could leak. Somebody could accidentally do something else with it. But in order to figure out, what people sort of claim is, well, you should only use data that you need. But often in these types of systems, you don't know what you need until you try it. So there is this tricky first step of collecting the data to test whether it's necessary, and then not collecting it further or not keeping it. But that first step is kind of tricky, and I don't have an answer, but it's something just to think about, is like even trying to figure out what's necessary requires the collection of it. And we don't really have good ways of doing that today without kind of collecting in the first place.
Yeah, I think these 2 points you're making are key. The first one about not just collection, but also use. And this new question that companies are facing about, even if people have agreed to the collection of their data, have they agreed to the usage of their data, or even the usage in a particular way? For example, in my car, I have a little tracking device that State Farm has given me that tracks how fast I go, how quickly I go around corners. Oh, interesting. So we have some dissenters. But I have given them permission to use location data and perhaps data about speed for these purposes, but maybe not others, right? And there are other kinds of purposes they could use that data for. And I haven't necessarily consented to that as well. The second thing you point out, which is a common theme in ethics of new technologies, is, of course, that regulation here is very sparse. We have old regulations in healthcare and credit, but for these new applications, it's hard to figure out how they work. And that actually transitions to our next question here about transparency and explainability. So in certain areas, like for instance, credit in the US, there are regulations where if you apply for a loan and you get turned down, the company has to say under the Equal Credit Opportunity Act, here's why you got rejected. However, there are many companies like Bank of America which are using new credit scores, like for instance, the Credit Optics score designed by SageStream, which is built on a large data set. It's based on a complex model called a convolutional neural network. And this kind of model is very hard to trace the particular path that the model took from inputs to outputs. So when you ask, why did the model reject me? Even the engineers who built this model will often say, I don't know. This is, it's almost impossible to figure out the precise path that it took. I can maybe give you some very general statements about it, but not precise ones. And so I want to ask about that, not just in credit, but also healthcare and other areas. When we're building these very complex models on large data sets, what kinds of challenges have you seen arise with explainability, with understanding how these models work, both from the engineering perspective of the people building the models and explaining them to the users who are impacted by these models?
Yeah, so is this working? Okay, so, sorry. So that's a great point. So, there are black box models, right? It's always possible to know what the inputs were, right? Where someone is putting the data into the model that it's trained on. We know what the outcomes are. There are certain kinds of models that are very hard to know exactly why it's choosing certain things, although most of them will at least tell you what was important versus not important. You don't get coefficients like you do out of a regression model or something, but you can say, the model found these 10 things were the most important of everything we fed in. This is what this decision is based on. Sometimes that's okay. So for some purposes, that's perfectly fine. We don't need to know, are these two things really number 3 and 4 or number 5 and 7? And what I would say is when that does matter, we probably rethink, what kind of model we're using and what are we using it for. And if something is that sensitive to what the important factors are, maybe that's the wrong kind of model, if we can't explain to the degree necessary. But also, I would also like to say that not everything is machine learning. There are a lot of different ways to solve a problem, and that's what my group does in R&D, is we try to choose the best method to solve the problem. And in a lot of cases, if you know how to solve the problem, you don't need machine learning. You can use a linear program or, regression or whatever the case may be that, is far more explainable, far simpler to explain to people. And if that works, we always go with the simplest possible method.
Yeah, and I want to keep that in mind too before we move on to Rayid, and I'm sure Rayid will agree with me on this, that AI is much older than machine learning and not equal to machine learning.
We're the business school, it's all the same.
Right, that you can, that the robotics department here at CMU, we're programming robots to move from point A to point B without machine learning for decades. And there are lots of ways of using inputs to make decisions without using these very complex, hard to interpret models. But yeah, please.
Yeah, so I mean, I think I guess the overarching question for me becomes, we're talking about explainability or transparency or any of these things, it's compared to what, right? So today we have these very transparent and explainable systems called humans, right? They explain everything, they're totally transparent, they have no bias, they have no issues at all, they're just perfect. And these machines are coming along and just destroying the world. All ethical issues are with machines and humans have no issues. So not that I'm saying the machines are perfect, they're horrible. But in order to decide whether you want to use a system, you have to kind of compare to the existing system, which might be human-based. And the new one may not be automated, it may be human and machine-based, right? So in some ways, the explainability of the entire system is the combination of the machine and the human taking actions based on it, compared to the human. Now, when we get to the teaming, because explainability is not a concept that you design for machines. You're not explaining to a machine. They're explaining to a human. So then it gets complicated because there's no such thing as kind of general purpose explainability, because it depends on who is being explained to. If it's an expert, a technical expert, if it's a medical expert, if it's a consumer, in the case of the adverse action notices that you're talking about in financial services, very different consumers of that explanation, which means the explanation has to kind of take into account the purpose of the explanation. So a lot of the things we do in this space is, one is trying to split up, like what is the need for this explanation here, right? In the recourse or the adverse action notice, it's not just to explain why you took an action, why you denied them a loan, but also if they were to do these things, you will then be able to give them a loan. And so in this case, you better, whatever you gave them with a machine, you can change those things and say, does it change what the machine would have said? And does it change the loan decision? If it does, it's a good enough explanation because it achieves the purpose. What the model is in the back, how it works, what it does, has nothing to do with in this use case, right? If the use case was, well, I am a clinician and I'm dealing with substance abuse disorder and I have 3 different drugs that I could give this person, I'm not sure which one. And this machine sort of predicts, well, this person is high risk of opioid use disorder or relapse, which of these 3 drugs will be more effective? In that case, the explanation is not just a generic explanation, it's trying to help them decide which intervention to take. Versus you're trying to sort of figure out how to debug a system. You're a technical developer of these systems, you just built it, you're not going to show it to somebody else unless you can understand it yourself. That's a very different explanation. So I think today what's been happening is over the last few years, the technical AI machine learning world has been working in this space of explainability. But right now we're very, very, very early. And we sort of are working on these general purpose things where what we need is very much specific to each use case and the type of consumers of this information, and then designing each thing separately, because I don't expect a general purpose thing to come around that's going to be like, here's explainability, right? Because that's the only explanation of a machine learning model is the model itself. Everything else is something else. But if something else is useful in helping make a decision, then let's use it. We can call it whatever. So I think that's at least the way we think about it in a lot of our work is really, how do we augment this system with other things that help the human downstream to make better decisions? And I mean, we can call it something else, but not an explanation, because it often isn't.
Yeah, that's wonderful. And what I hear as a common theme between both of your responses, the importance of humans actually making judgments about what kinds of models are appropriate and what kinds of explanations are appropriate. I love what you were saying, Michael, about the decision even about which models to use depending on what the stakes are, what the possible outcomes are, whether you're using this in your business operations to figure out supply chain issues, or whether you're using this to diagnose melanoma. These are very different applications. And what Rayid's talking about, this is an issue in terms of human explanations, which goes back and predates AI, obviously, when, for example, doctors need to figure out how to explain treatments to patients in a way that gives them power, gives them autonomy and control over their health outcomes, even though those patients might not be able to explain or understand, I should say, what chemotherapy is. The patient should have perhaps a minimal understanding that allows them that control. Good. So the next question I want to turn to is about discrimination and inequality, where we have, in the use of these giant data sets, all of these biases and inequalities, which then get, in some cases, actually put into the models and the decisions of the model itself. This can happen for many reasons, because the model was trained on a small or biased sample set of one particular group. It could happen because there's bias in the labeling of humans who actually labeled that data. Or it could happen just because of historical inequalities in the data itself. But for either of those three reasons, those inequalities, those biases often show up in the models. One example of this is, there are plenty of these, dozens of these that we talk about in ethics and AI courses. But one of them is from Optum, where there was a Washington Post story a few years ago indicating that black and white patients were mistakenly classified in terms of their health outcomes. Now, this was an inequality in the error rates, but there are other ways of measuring inequality here also, and we won't go into all those technical details necessarily. But the key thing that we want to observe here is that oftentimes, when you build a model on historical data, those same historical inequalities show up in the model, right? And so I want to ask, in what ways have each of our speakers seen those problems in the real world? Have they seen companies address these problems?
Yeah, so I'll just touch briefly on the Optum situation. It was 3 years ago, end of 2019, and the problem there was a lot of discussion amongst my colleagues when that came out. The model did exactly what people told it to do, right?
Exactly.
Computers are stupid. They have no common sense. They'll do exactly what you tell them to do. And the mistake here was that cost of healthcare was used as a proxy for health. And because minority people, people of color especially, don't receive the same level of health care and in the same way as other people, the disparity in cost, it doesn't equate at all to their level of health. So what the model did was essentially said, people of color have lower cost, they must be healthier. And I mean, that's what happened. And it was, it was just an extremely poor use of a model of that kind, without anybody really giving it any thought. And so what we do, what we do most and foremost is ask a lot of questions. So this human in the loop thing has to start at the very beginning and go all the way through, including follow-up after the fact on how a model is used, how it's built, what goes into it, what's the problem we're trying to solve. So when business people come to me, business owners or clinicians, we work on a variety of different things. They have some problem they want us to work on. My first question is, once we understand the problem, which could also take some time, my first question once we arrive at what this thing is that we're going to predict is, let's assume I can predict with 100% accuracy what you want me to predict. I'm going to build the perfect model. What are you going to do with it? What's the action? What will you do with this information? And you'd be surprised. A lot of times that question doesn't get answered. They don't know. And I say, well, come back when you know, because I can't do anything. We can't do anything that makes any sense without knowing what you're going to do with it, because of the different kinds of harm that will come from the mistakes and the errors that come out of the model. No model's perfect, right? So if they do have a decent answer for that, they say, okay, well, we want to reach out, in a proactive way, and suggest to these patients who are at really high risk, maybe when they get a chance, go see your PCP. It's been a while since you've seen your PCP. You're at high risk for some things. Go find out, right? So then, if that's the case, what we do is, depending on what the action is, we look at, okay, the next questions are, all right, what happens if we flag somebody who shouldn't have been? What happens if we fail to flag somebody who should have been? So false positives, false negatives. What's the harm in each of those? And we actually spend quite a bit of time understanding that harm and tuning the model one way or the other to minimize that harm, right? So there are certain things that we've done where false positives, so I'll give you a specific example. In the Cancer Institute, we're predicting patients who are at high risk of visiting an emergency department during the course of their chemotherapy treatments. It's fairly predictable. It's a serious problem. Almost half of the patients who are in chemotherapy end up in an emergency room at least once during the course of the treatment, and close to a third of those patients are in an emergency room more than once. In a period of 6 to 12 weeks, it's not a good situation. So we want to try to do something about that. So what we determined was we can predict pretty well who is at high risk. The action was that we pay extra attention to those people. They're in for chemo 2-3 times a week, so people are seeing them on a very regular basis. And if we have that flag in front of the clinicians, they can ask the right kinds of questions. How are you feeling? Have you had any trouble? Are you dehydrated at night? Those kinds of things. We might be able to do something to help keep them out of the emergency room. And what we determined was, when we tuned the model, was that false positives weren't an issue, right? So, a potential harm, if you will, for the false positives, where we're paying extra attention to someone who maybe isn't going to end up in the emergency room. So a potential harm for real is we're spending more time, some clinician could have been spending time with someone else, right? So that's valid. On the other hand, everyone coming in for chemo needs some attention. And if it ended up that we needed to add staff or adjust staff schedules to accommodate that extra time that's spent on these false positives, we determined that was totally insignificant compared to the good that might come out of that. So that's the kind of thought process we go through, and it's the kind of thought process that has to be gone through for every single thing we do. And then after the fact, we also want to follow up and make sure that over time, that action doesn't change without our knowledge, because that model is built for a specific action. And if that action changes from proactive to reactive, for example, our false positives and false negatives might be totally upside down. So we have to keep an eye on those things too. And so we build all of that into our processes. We track model performance over time, we track drift. We have a whole group in our advanced analytics department that does nothing but evaluate after the fact. Are these models doing what we thought they would do? So all of those things are really important. I could ramble forever, but so I get involved in a lot of build versus buy conversations. I've done a lot of vendor reviews, and the first thing I notice in general is that, we get a lot of vendors who come in and want to help us with the easy part. Right? And the first thing that turns me off about a vendor when they're pitching something is they're not asking any questions, right? They know everything there is to know, right? They don't ask us any questions about what's our patient population, what's our member population, and without knowing those things, I'm not exactly sure what they're going to do. It's frightening in some cases.
Good. Before turning to Rayid, I want to emphasize two things that you said. One of them is, it matters what you're optimizing for. That we've seen this in advertising, where if your advertising is just optimizing for clicks or time on site, then you could wind up producing these terrible outcomes. that wind up destroying things like democracy. But the other thing that I want to emphasize is that false positives and false negatives are not always the same. If you're just, like you said, looking at maximizing accuracy and you're just doing, well, my true positives plus true negatives out of all the outcomes, and that's accuracy rate, 86% accuracy, yay, right? But if, like you're pointing out, false positive is spending a little more time with the patient, false negative is missing somebody's cancer, that is a serious problem. Even in advertising, if one error is not showing somebody baby ads, which is bad for the company, but not a big deal, and another error is showing somebody baby ads when they're not pregnant or they've just miscarried, that is terrible. So it is important for humans designing these systems to keep in mind, what are we optimizing for? What are the false positives and false negatives in the real world? What effects do those produce? What are those effects on these different underrepresented or disadvantaged groups too? Good. So please, Rayid as well.
Yeah, no, I mean, exactly what both of you said, right? Like I would have given the same spiel, so I'm going to skip that. Yeah. No, but I think the challenge is that this process is not standardized and it's not documented. So it's not as if everybody's doing this. Right? There are very few teams that are building these systems that are having these conversations about, well, what would you rather have? What's worse, right? Because it's not, most teams start with saying, well, what do you want to predict? I don't care what you want to predict, it's what you want to do with it, right? So for example, there's a lot of sort of, when I tell people, well, sometimes, I build systems to predict who's going to commit a crime, right? That's horrible, because what happens, actually I do this in class, where we're saying, predicting somebody's going to commit a crime is unethical. And most students, we play this spectrum game, most students go, yes. And then I say, predicting somebody's going to commit a suicide is unethical. They disagree. Like, well, I'm predicting some behavior about some person, why does it change? And they are taking the next leap and saying, well, if you predict they're going to commit a crime, you're going to do something horrible to them. But I think if you predict you're going to commit suicide, you're going to do something good for them. But that's the assumption we're making about the next step, which is the most critical step, as Michael said. It's not about the prediction. And so I work with a lot of mental health organizations to help them provide proactive mental health services to people who might get stopped by the police, right? So the prediction of crime is really not a prediction of crime, because we don't have any crime data that's accurate, but we do know who the police stops. And if we can help them and prevent that stop and that interaction, that prediction is much more ethical, in my opinion, than the predictive policing horrible things that people do, right? But the prediction might be the same. It's the intervention that's different. But because the intervention is different, how I tune my system to weigh false positive. In this case, false negatives are much worse. If I miss somebody and I say they're not going to be stopped by the police and they get stopped, that's bad. But if I predict they're going to be stopped by the police and I'm wrong and I just help them anyway, I think they're just getting mental health service, a call. So again, so I think this is not a standard process. People kind of come up with it. The other thing I'd mention, just because this is what we've talked about very well, is we sometimes blame the data for the bias, right? And data plays a little bit of the role in the bias, but I think what Michael said was these systems do exactly what you tell them to do. And yes, you can give them bad data, because all data is bad. That's just, Even if it's perfect data, it's biased because of healthcare practices, because of financial services, because of society, right? People are biased. They generate processes that are biased. If we collect perfect data on all those, we'll still be biased. But then when we build these systems, if we tell them your job is to get as many things right as possible in this historical data, so a lot of the biases that come from, let's say, if we're building a system for face recognition, and it has, the data that's coming in, let's say it's not biased for once. But if you wanted to get most things right in this data, well, it's going to get the majority of the people right. In this case, the majority of people happen to be, let's say, male or white. If you've asked the system to get most things right, most AI systems, ML systems, are pretty lazy. They want to do the minimum work possible, just like us, hopefully. And so to get the right answer, and the right answer is getting most of these right, and the easiest thing is just to pick up on this little clue, that's what they do. Now, if you want equity or fairness in there, then you have to tell the system, I want you to get most things right, And I want you to make sure that your error rates are not different across these groups. If you don't tell it that, how is it supposed to know that you care about these things? Maybe it thinks that, oh, you want all the people wearing white shirts more important than wearing not white shirts. It doesn't know these things. And today, our design process for these systems doesn't include most of it, the standard process, right? You have to kind of go out of your way. If you picked up an off-the-shelf machine learning system, it doesn't do any of this stuff. What it really is good at is doing what's happened before and doing it much more efficiently. So it scales if the history was biased and inequitable, it's gonna scale that much cheaper. It's really good at that. But that's what we've historically used it for. And now we're trying to use it for other things, and we're saying it's the same system and it's not working. So we have to kind of redesign these systems to get to what we want rather than what they were kind of just doing off the shelf. And again, that's not a solved problem at all. It requires lots of conversations and lots of processes and lots of monitoring and lots of all this work. So hopefully we'll get there.
If I could add two more,
Please.
just a couple more points on that. These discussions that we're talking about, where you review, what is it we're really trying to solve here? What's the action that's going to be taken? What's really important in those discussions is diversity. Not only diversity
Just
as
like
we think
here.
of with, ethnicity, religion, gender. Those things obviously are extremely important. But diversity of experiences, diversity of prior contact with these kinds of things, right? So when I put my group together, which now consists of 15 brilliant people, 2 of whom are back there. I really went out of my way to hire people from very different backgrounds. We're all working in healthcare. We're all working on the same things, but I've got a person who has a patent on a steel alloy. I've got a woman who was on the LIGO project when they got their black hole merger, the first one. Ruth back here is trained in neuroscience. So, it's a very diverse group. And so we're able to think about these things from a lot of different angles. And we're able to have really good discussions about, and say things like, well, wait a minute, I don't know if that makes sense. Like, what if what if this happened? We ask a lot of what if questions. Those are really important.
Yeah, and I mean, to your point, the action also matters because sometimes it's not the technical system that's causing the bias. It's the intervention, right? And so one of the projects I was doing years ago was with the Chicago Public Health Department on identifying kids who are going to get lead poisoning and trying to be preventative in sending inspectors to their home to kind of check for lead hazards so they could remove them. We've spent a lot of time making the system, let's check for fairness, check for bias, and it all seemed good, and then we tested it. And we started seeing, disproportionate inspections being made on missing Hispanic individuals. So we looked at, just shadowed the phone calls, and it looks like all the phone calls were happening in English, right? And it's not the computer, the algorithm, the machine learning that's the problem, but the system is not just the algorithm. It's this human who's making phone calls. So people pick up the phone and they would just hang up. And same thing, a lot of programs that do digital interventions, that it's not, so you kind of have to look at the entire chain from the bias coming from the world, from the data, from your machine learning system, from the interventions, and sort of try to figure out where is it coming from. Because fixing it is not, it depends on where it's coming from, right? You would fix it over there. And so again, even that process of, well, let's not just throw the system over the fence. So we have to monitor the interaction. How often is the system somebody overriding it? Because you give a recommendation, maybe half the time they do it, and half the time they don't do it. That's not random. If they always ignore certain things, they could be making the bias worse, or they could make the bias better because they realize where it's being biased and kind of fix that. So the monitoring each component of it is so critical in doing this right.
Excellent. So I want to have time for Q&A, so we will go ahead and shift to that. But I want to emphasize that what both of you have been saying, is something that we teach in ethics classes all the time, which is that the crucial thing here is human decision making in the process, constantly thinking about these problems. What are we optimizing for? How are we measuring fairness? How are we measuring benefit? Exactly what do we want from the system? And never being satisfied with just letting it run on its own as Michael was saying. Okay, so please, questions for our panel.
Is there any effort to sort of standardize how people think about this? Because UPMC could be doing a phenomenal job at the ethical creation of models and application and so forth, but 99 hospitals aren't. And you might be doing a great job, but somebody else is doing a great job in other ways. And there's so much to learn and so much to benefit consumers by some kind of a standardization over time. I know we're really early. I just wonder if anybody's thinking and talking about this.
So we are, like you said, we're very, very early in this game, right? Some of these things are extremely new. I think we at Highmark are ahead of that game, based on some conversations I've had with other systems and other health plans. There's no standardization across different systems that I'm aware of. Although, one of our goals as we partner with some other systems, we have partnerships with Penn State Health and ChristianaCare in Delaware. We want to start to roll these things out to them. We have partnerships with other Blues plans where we do claim processing for other Blues plans in other states. So we can kind of push this out to them as well, and hopefully, there will be enough momentum that other people will see the benefit. Beyond that, we also have executives who travel frequently to Washington D.C. to take an active part in future legislation and discussions around that, where we're really trying to do the right thing for everyone across the board. It's not easy, obviously. So not all companies have the same motivations. We're in a fairly unique position because we're a payer and provider. A payer-only system or a provider-only system, they have very different motivations than we do. We're able to really try to look at healthcare across the entire life cycle, right? So, from the health plan all the way through to, hospice, death, we look at every aspect of it.
So I think there are a lot of efforts going on the regulatory side across industries, but when I mean a lot, actually a lot, and it may be too many, because every large city, every large county, every large state, every large federal agency has a few of these frameworks they've been putting together for the last several years. And a lot of them they sound very good, they have all the right words, but they're not operational. You can't actually do anything with them other than read them and say they sound great. And I think that's sort of the gap. Is the standardization right now is at too high level and not at the operational level. And I think that's the struggle that everybody's facing. Is a lot of organizations, as to Michael's point, don't want to. Okay, tell us the process. Don't regulate us on the values, because if somebody wants to value profit over equity, well, we should regulate them not to allow them to do that. But if you just say, well, you should check and make sure that you talk to all the stakeholders. Well, we did. And that's a lot of these things. You should talk to stakeholders. You should make sure you have these discussions. You should make sure you document things, but you should make sure that your system is resulting in equitable outcomes. That's the regulation. And then they're kind of falling short of that. They're sort of just doing this high-level thing. Yeah.
Do we have time for one more?
Yeah.
Okay, while you're finding somebody, I will say, on my more optimistic mornings, I like to think that this is a dynamic process where we start out with these very vague-sounding commitments to fairness and explainability and benefit, and then over time that there are industry norms and standards that develop and that will coalesce. At least that's my hope.
Or, taking the advice of Mr. Firestone, we could all work for unethical companies and become whistleblowers and make a lot of money.
Okay, that's fair. Fair point, yes.
I mean, there's a lot of money. There's a lot of money to be had there.
Please.
Okay, thank you guys. Have there ever been any violations of privacy in the law? Are there legal pre-qualifications for onboarding new hires to work with the models that you guys work with?
For us, yeah, very much so. Like I said, everyone goes through training. A new hire typically takes about a week, full-time for a week, to get through most of the training that we offer, and then there are periodic updates and, and refreshers that we all do on a regular basis. And beyond that, it's the culture. The culture is so important, right? So our culture is we try to do the right thing for people. And it says it all. This is a business school. It's been a known fact for quite a long time that if you do the right thing for your customers, for your patients, for whoever, if you're doing the right thing for people, the business will follow. But it's amazing how many companies, and I've worked for companies that don't look at it that way. It's odd in a way, but I think we look at it that way, and we've had a lot of success.
Excellent. Well, I think we are out of time, so thanks very much to our esteemed panel.
Thank you.